Exercise 183, page 462, question number 11. We've got a formula for the average voltage equals 1 over pi, integral between 0 and pi, of this wave function, 10 sine omega t, 3 sine 3 omega t, plus 2 sine 5 omega t, with respect to omega t. Notice the omega t, if we think back to our work on angular velocity, omega times t is actually theta. So this is theta, this is theta, this is theta, and this is theta. So we're integrating with respect to all of this omega t and calling that theta effectively. So that's going to make the integral a bit easier. If we look at this wave function, 10 sine omega t plus 3 sine 3 omega t and so on, we get this wave function underneath that you can see. It looks a little bit like a step function, and in fact this complex wave function is arrived at by Fourier analysis, and the more terms we add to this wave function, the more it looks like a square function. If we look at this function for a minute in detail, this part of it, the omega t, is the fundamental rate at which this thing that's oscillating is producing this wave. And then we've got the next term, which is 3 times that, so that's called the third harmonic, and the fifth harmonic. These are odd harmonics, the first, or the fundamental, the third harmonic, the fifth harmonic, the seventh would be the next odd harmonic, and so on. And the more of those we add, so some value sine 7 omega t plus another constant times sine 9 omega t, and so on, the more terms we add, and Fourier analysis will allow us to add these terms, the more this would look like a square wave. So that's where this wave comes from, and we will be using Fourier analysis. So when we come up with a complex wave like this, it's not uncommon to have to integrate it. We're after the average value for the voltage that this wave is producing. So let's just have a look at that in detail for a second. I'll just get rid of these. So I've actually taken this part of the wave here and expanded it out underneath. And if we look at it, there it is. And so the period of this half of the wave is across pi. This is pi from here to here. So if we think of the average value of the voltage, that would be some value maybe about here somewhere, some sort of average value for the voltage. And if we take that area there, then the integral, remember, gives us the area underneath the curve. The integral gives us the area, this area here, underneath the curve. But the area also equals, if we take the average voltage, just for a rectangle, the average voltage multiplied by pi. This integral across here would give us the same area. So if we want the average value, that's going to be the area, which we can find by integrating it, divided by pi. Or in other words, the average value equals 1 over pi times the integral, which is effectively, or exactly rather, what we've got here. The average value is 1 over pi times the integral of the function. And that's always the case. To find an average value, it's 1 over the integral, in this case, which is pi, times the integral across that interval. So between pi and 0 gives us an interval of pi. And that works for any function. Okay, so we're going to find this average voltage by integrating this function. So let's have a go. So here's the function. Remember, what we're integrating with respect to is omega t. So the whole thing, which we may as well call theta, or we could easily have called theta. So let's just take each part and integrate it in turn. So the average voltage is going to be 1 over pi. So the integral of 10 sine theta, the integral of sine is cosine or minus cosine. So that'll be minus 10 times cos omega t. The next one, sine becomes minus cos, so that'll be minus 3. And the 3 comes out of the integral, so it's minus 3 over 3 cosine omega t. Minus 2 over 5 cosine omega t, or 5 omega t, and 3 omega t. I left those out. 5 omega t between the interval and 0 and pi. And then we just put the limits in. So see if you can finish from there, not forgetting that omega t equals pi, which would be the first limit to put in. So the average equals 1 over pi. And we could take the minus sign outside, so minus 1 over pi outside, so that would leave us 10 cos omega t is pi, minus, plus, because I've taken the minus sign outside, 3 over 3 cancels, cos 3 pi, plus 2/5 cos 5 pi. So that's the first limit put in. Minus, put the second limit in, 0. So the whole thing inside becomes 0. So that's 10 cos 0 plus cos 3 0, 3 times 0, which is 0, plus 2/5 cos 5 times 0. See if you can finish from there, but remember what the cosine wave looks like, and so see if you can simplify it without using the calculator. Remember what the cosine wave looks like. That would be an integral of 2 pi between minus 1 and plus 1. And so if that's 2 pi, this is pi, and that's 0. So we could just use our knowledge of what the cosine wave looks like for the next step. The average voltage is going to equal minus 1 over pi right, the first one, cos pi, is minus 1 according to that, so that would be minus 10. 3 pi, well, if that pi is minus 1, then 3 pi will be minus 1 as well, so that's plus minus 1 plus 2/5 of cos of 5 pi, which again is minus 1. Cos of 0 is 1, so that will be minus cos of 10 times 1 is 10, plus 1, cos of 0 is 1, plus 2/5 times 1 is 2/5. So we work out what that is inside the bracket, and hopefully we confirm what we get in the textbook. There's a solution worked out.